Hi, and welcome to this lab section on SQL Foundation for Data Analytics. In this lecture, we will look at the basic SQL commands and the functions which are essential to learn in order to perform analytics using SQL. SQL is a programming language used to communicate with data stored in a relational database management system. SQL syntax is similar to the English language, which makes it relatively easy to write, read, and interpret. It is used for relational databases to access and manipulate the database. American National Standards Institute has made SQL a standard language in 1986, and International Organization for Standardization has declared it in 1987 as a standard language. There are different versions of SQL used, but all of them have support still for common features, among them which include the select statement, the update, delete, insert, and where statements. SQL is used to perform queries on a relational database. It is used to run the queries, to retrieve data, insert or update an existing record value, create or delete the records within the database, create new tables in the database, generate tabulated views of the dataset values, and it can also perform a set of permission on tables to view and apply different procedures. A relational database management system is a program that allows you to create, update, and administer a relational database. Most relational database management systems use the SQL language to access the database. In our next lab session, we will see some of the basic SQL commands that can be used to manipulate or retrieve the database. Hi, in this lecture, we will have a look at some basic SQL commands. Before we go deep into the lab sessions, let's first look at the syntax and have an understanding of them. A database most often contains one or more tables. Each table is identified by a name. For example, customer or orders table. Table contains records or rows with data. The table shown here is a selection from the customer table. In this tutorial, we will use the well-known sales record database. Most of the actions you need to perform on a database are done with the SQL statements. This statement select all from customers, semicolon, shown here selects all the records in the customer table. Some database system requires a semicolon at the end of each SQL statement, and it is the standard way to separate each SQL statement in database system that allows more than one SQL statement to be executed in the same call to the server. Here are a few important SQL commands that are used when querying a database. And these are a list of other operators that can be used with the where clause. Now let's move to the lab practice sessions where we will have a hands-on practice on SQL queries. Hi, and welcome to this lab session. Here we will be executing the SQL queries on the sales record dataset we have already learned to upload to the database in Azure Synapse. We have previously seen how you can bring in your data either in the SQL database or Azure Synapse SQL pool. Let's begin with some queries on them. We will go to the Data tab here, and you will see the two options here, the workspace and the linked. Select the workspace option. Under this, you will find the database which has our SQL pool 1 we created. Under this, you will see that we have this table folder. And in this, we have our three database tables, the dispatch items, the item sales, and the sales record 50K. Now we will use these datasets as a sample to perform our queries in SQL. Let's go through the select statement. So we will look at a SQL statement to get all of this table data in your output result. For that, we go to the Develop tab in the sidebar. Select the Add option and go for the option of New SQL Script Editor and write this statement. Let me write the select all statement. So we write select asterisk. So this symbol means you want to fetch all of the data which are in the table you want the data to fetch from. Then we type the from and give the name of the table. In our case, the name of the table is dbo dot, then the name of the table. But right now, even if I give the table name, it won't fetch result because we have connected this SQL script to a wrong database. For this, you need to go to the drop-down and select the SQL Pool 1 on which we are working right now. Let's select the SQL Pool 1. Now let's give the table name, which is sales record 50K in our case. Now let's run the query. And the script is running as of now. Okay, so here you see that it gives you all of the data in the output, showing that it returned all the results in the table that we have. If you are keenly interested in looking at all the rows, then you can select the Fetch All Rows option, so this will give you all the columns of your dataset. To just view the table is not recommended as it takes much time also. It takes much usage of your free tire as well. So this does not affect your answers anyway. If you are wondering about applying the aggregation or other numeric functions, the answer will include all the data points in the calculation. So this is all for this lab. In our next session, we will see how to select a single column or specific values from the dataset. Hello and welcome to this lab session. Previously, we have seen how you can select all your dataset values in the available dataset you have. In this lecture, we will see how you can select specified or required columns out of the complete dataset. So for that, let's write the statement select. For example, here for the sales record dataset we have, I am interested in the country. You see it automatically says that this column is present in the sales record 50K table. And the item type column is the one that I need as well. Next, we will tell the statement from where we want these columns. That is from the sales record 50K. And you can see it automatically suggests us, so I will click on it and select it. Alright, so these are the two columns that I'm interested in. Let's run the query. Here are the results. We have the country and the item type, and these are the data points that are available in our dataset. The point to notice here is that on the right side we have two options. Currently, the option for first 5,000 rows is selected. This means out of 50,000, only the first 5,000 will be displayed to us. But if we select the All Rows option, it will bring all the data in the results section. But that is only recommended if you really want to see all the data. Else, it can affect your free tire and cost you more. So this is how you perform a script in SQL to select a specific or multiple columns in the Azure SQL pool. Same can be applied in the SQL database as well. Hello and welcome to this lab session. In this lab session, we will look at how you can see the distinct available values in the column of your dataset tables in the database. Here, if you see in the region column, we have Europe, Sub-Sahara African, Asia, then we have got Central America and so on. Likewise, if we go and see the sales channel, we have got online and the offline spread out throughout the dataset table in the sales channel column we have. So how you get the distinct names of all the values present in the columns, either region, item type, country, or any of them. So here I will write select distinct, and here we want to look at the region, and then we write from where we want, That is sales record table. Once when we run this query, you can see here we have all the different regions that exist in our dataset. Count them and they are all 7 in numbers. Alright, next let's see the sales channel as well. So for that we will select the sales channel in the distinct statement. Let's run this query. So here you can see we have only 2 different types of channels, that is online and offline in our complete dataset. This is how you perform the distinct operation in SQL, using which you can see the distinct values in each column for your dataset. In our next lab session, we will see how to count the values in the dataset table and also how you can count the distinct available values. Like over here, it was easy to say that we have 7 different distinct region names. What if the values were large and not easily countable? Hello and welcome to this lab session. In this lab session, we will look at the count statement and count distinct statements in SQL to count for the values in the specified column. We have previously seen that on looking at the distinct values for the regions, we got 7 different values that exist in the dataset. Also, we know that we have a total dataset count of 50,000. Let's verify that with the help of the count statement. So, write select, count. Now let's say I want to count the total number of regions in my dataset. So I will type the count region and then I will select it from the sales record 50K, which is my dataset table name. Let's run it. And obviously it will return me 50,000 as we have 50,000 dataset values. Now let's say we want to see what are the distinct number of region names that exist in our dataset. For that, we write the term distinct with the selected column name. This will basically count for you the distinct regions that exist in the dataset. Let's run it. So you can see that it returned 7 as an answer. This is because we have 7 different region names in our complete dataset of 50,000 data points. There is one more method by which we can count distinct values. That is, we write select and then approx count distinct statement. In there, we write region as argument and we want it to select from the sales record 50K table. Now let me select this line to run it. So you see that it again returns the same answer. You can perform the distinct count operation using any of the 2 methods. Let's make a little bit of understanding clear by checking out the count for the distinct country. So over here I will type in the country instead of the region and select this line and run it. Here we get answer 185, so we have 185 distinct country names in the complete dataset of 50,000. So this is how you perform the count and the count distinct statements in SQL and get the total count and the distinct count for each column in the dataset. In our next lab session, we will see the use of where statements in SQL. Hello and welcome to this lab session. In this lab session, we will see how to use the where statement in SQL and where do you use it. Until now, we have used some simple statements like count, count distinct, select operations. The where statement is used for a condition check, which means that after the where clause, you write down the condition on which you want your query to be executed. If I only write this condition, it will select all the 50,000 dataset values from this sales records table. But when I give the where statement with the condition, then it will only be executed for the rows where the condition meets. Let's say we want to select everything in this dataset but with a condition that the country name be Russia only. Or maybe you might be interested in looking for a specific condition on sales channel. How to do that? Here I will add the where statement, where the country name should be Russia. And for that, I will type down where country equals Russia. What will happen now is it will execute this command, and after execution, it will only provide me the output data set for the rows that will only contain the country name as Russia. Let's run it. Here we get the output, and if you carefully analyze it, we get the output rows only where the country name is Russia. Rest all other country name data values are not displayed as they don't meet our condition. This is the power of the where statement, where you can write down the conditional statement on which you want your main query to be executed. Let's have a look at another example. Now, let's say I'm interested in looking at the units sold. So basically, I want to see the output rows where the units sold are greater than 1000. For this, I will add where units sold is greater than 1000. Let's run it. You can see here that we get all the output query results having units sold value greater than 1000. Let's take another example. This time I'm interested in looking at how many rows are there in my dataset which meet this condition of units sold greater than 1000. Because I can't go individually to each of the data in the output, so it will quickly let me know the instances meeting the required condition in the dataset table. To achieve this, I will write down select count. So this statement will give me the total number of counts which meets this condition. Let's run it. Here is the result, and it says that out of 50,000 rows, there are 44,925 rows that meet our specified condition. Let me quickly change this condition to 0. It should give us 50,000. Great, here it is. So this means that our dataset contains all the rows with the non-zero values. In the same way, you can check for your required condition as well. In our next lab session, we will look at how to perform the logical operators like AND, OR, and NOT in SQL queries. Hi, and welcome to this lab session. In this lab session, we will look at the logical operator AND, how and where it is used in SQL statements. AND operator is basically performed when you want two or more conditions to be true at the same time. AND operator is used with where statements most of the times. Let me type down the SQL query for you. Using the where statement with a condition that I want to see the online sales. And so this AND here will satisfy the first condition as well as the second condition that I will state after this. The output result will only show the query results that meet both conditions. The next condition I want is the Europe region. For that, I will write down region equals Europe. After I run it, this will give me the result that it has a sales channel as online as well as the region as Europe. So you can see over here we have all the outputs that contain the region as Europe and the sales channel as online. In the same way, we can also select some specific columns with the same condition. Let's select region, country, and the order ID from our columns. And if we run this, it shows all the output with the condition that we provided in our SQL script. Now let's say for this specific condition, we want to look at the total count, like how many order IDs are there with this condition. I will remove these two from here and add the count statement in the script. This will give me the total count for the orders that were there with this condition. So we have 6,449 orders that were placed online from the Europe region. This is where you perform the AND statements. In our next lab session, we will learn the OR statement for the same criteria and compare this result. Hello and welcome to this lab session. In this lab session, we will see the OR operator in SQL Queries. An AND operator is performed where you want both the conditions to meet, and an OR operator is performed where you want either of the two conditions to be met. Here is an example query for the OR operator. This statement basically says that select all from the sales record database table for the condition where either the sales channel is online or the region is Europe, which means that for any row having any of the two conditions true will be shown to us in the output. Let's run this query. Alright, so you can see over here that for this case you have the sales channel as online selected for us and the region is all where it is Europe. So what you see here in output is for all of the Europe, the sales channel can be online as well as offline. And for all the online sales channel data points, the region can be Europe or any other region. Let's have a look at another query where for the same condition we will select only the country, sales channel and the order ID. Let's run the query. Here is the result for our query. You can see both online and offline in the result. But here the countries against each entry for the sales channel can be from the Europe region or any other. To have a better insight, let's have a look at the count for total order IDs that satisfied the stated condition. So you can see that there are 31,426 values that meet this condition out of the 50,000 data points. So this is how you perform the OR statement in SQL. Hello everyone and welcome to this lab session. In this lab session, we will see how to perform a NOT operation. Let's say I'm interested in selecting the region, country, the sales channel, and let me also add in the item type. When I run this, it gives me all the query result. Now I will add in a condition where not the sales channel is equal to offline. Now this means that I'm asking for all the results other than offline sales channel. And we know that we have online left other than offline in our sales channel. So the result will give me all online results. Let's run it. And here we go, we have all the results that contain sales channel as online only. Let's try out another statement where in the NOT argument, I will write that the region is equal to Europe. This means that I will get all the regions in the output except for Europe. Let's run it. And here you go, our first result previously was Europe and now we have all the outputs except for the Europe region. So this is how we perform the NOT operation. It can also be used in addition to other logical statements as well. Hello and welcome to this lab session. In this lab session, we will see how to use the update statement in SQL. It is one of the important statements in SQL and is used to update or modify your records. We already have some dataset values in our table over here. Let's see how the update statement works. Before that, using the previous knowledge of SQL we gained, let's run this query first. So when I run it, it will give me the row which has order ID as 8977511939. I am fetching this specific row for you in order to show first what the data is contained in this row. And then we will make an update to this row and see the changes. So you can see over here that this order ID has the region as Sub-Sahara Africa the country as Namibia, and other parameter values. Let's update the entry. For that, we write update, then the dataset table in which we want to update the values. Then in the next line, write set, and here I will set the country name to XYZ. So it will change the name of the country in order ID that we have set here for Namibia to XYZ. An important point to note here is that if you don't use the where statement or mistakenly omit this statement, it will update all our record, changing all country names to XYZ. So be careful when you use the update statements. Let's run this query. So the query has been executed successfully. It will not give any result, but at the back end, it will have updated the row. Let's again run this statement, fetching this row with the same order ID we updated. Let's run it. And here you see the result. The country name has been updated to XYZ. Rest all columns are the same. So this is how you make an update to the values in the tables using the SQL. If you want to update more fields, you type them also. Like after the country, I type region equals XYZ. So depending on your requirement, you can make changes accordingly. In our next lab session, we will see how to use the delete statement in SQL. Hello and welcome to this lab session. In this lab session, we will see how to delete a record from your dataset table using the SQL query. Previously, we have looked at how to update a record, and here I will be deleting the same record. First, let's have a look at the count of the total dataset we have. You can see we have 50,000 data points as of now. Next, let's use the delete statement. For that, we write delete from the name of the dataset table from where you want to delete any entry. And in the next line, I will give the condition where I want to select my order ID, and then I will give the same order ID used previously to update it. Okay, so before I run it, let me show you the order ID that it exists in our record. Let's run it. And here is the record that we are going to delete. Now let's run this command to delete it. So select these lines and run it. The query executed successfully, and now this entry is deleted. Let's verify it. We can see that one record was fetched as we have deleted this row, and this record value now does not exist in our table. Let's verify it also by the count statement. Select count all from the record table. This must now return 49,999. Reason being that one value is deleted out of 50,000. Let's run this query. So you see here we get 49,999 data points. This is how you can delete a record value from the table in SQL. In our next lab session, we will see how to add a new record row to your table. Hello and welcome to this lab session. In this lab session, we will look at how to use the insert into statement in SQL. Previously, we have updated a record and then we looked at how to delete it. As a result, you can see that we have 4,999 values as of now. So I have saved that raw value with me and will be adding that raw in our dataset table again. Here it is. In this, we are trying to insert into the table name, which is sales record 50K. If you look at it carefully, this was our order ID, which we deleted previously. And now I'm going to insert these values into this sales record dataset table. These are the values for each column. Also, if you see over here, we have written all these values to be inserted in the same order, as we saw in the output result. So what the query will do is map all the values in this order to the column cells and add these as a new entry to our dataset table. So our query has been executed successfully. Let's verify the execution. I will use the count statement to see for the total count of rows. So you see that we have a total count back to 50,000. Now let's go back to the query and search for that particular order ID that we have now inserted. This was the order ID in our case. Let's run this query. We can see that the output has been fetched and we have the details for this newly inserted order ID details. So now we have the complete table again with us and we are good to go to perform some analytic queries on it. In our next lab session, we will look at joining functions in SQL to join two different data tables. This lecture will help you understand the importance of join function and how we can actually use this function. Here are two different datasets for any superstore. Maybe they have two or more departments. Let's say a supermarket X has two departments. One might be a dispatch department who are dealing with the orders and other delivery to the addresses of a particular region. And the second one is the sales department who are looking for the sales details, their costing and relevant data. Now both of these datasets contain 50,000 rows value against their preliminary parameters. Like for the first set, which is the dispatch dataset, we have the upper level details like the order ID, units that are sold, the order date along with the region and country for that order. You can actually see this that the details are upper level and have nothing to do with the cost for units sold. We can see the account detail in the second data, which might be handled by the sales department. Here we have the details such as the sales channel. Either order was placed online or offline, the priority for each order and against the same order ID which is also contained in the first data set. It also contains the unit price, the unit cost, the unit total cost and the total profit. This is a type of scenario where any organization may have two departments among which one deals only with the dispatch related data and the other with the accountings involved with it. Let's say the boss of such company wants to perform some analysis like for a particular item, what number of units were sold, what was its unit price, the total cost and the total profit earned in different regions. Currently, all this data is in two different files, and in order to analyze the scenario mentioned earlier, all for this must be a single dataset file. This will help make the process smoother and quick. This is where we feel the importance of joining function. To join this data, we first need to import it there, and after this is done, using the join function, we will generate a single dataset combining these two. Here, the common value in both the dataset is the order ID, using which the query will combine the two datasets. After this, we will perform some statistical analysis on it to look for the details like what was the order date or item. Against each item, what was the total profit, or some other details like what region people are interested in which item. Hello and welcome to this lab session. In this lab session, we will look at how to use the join statement in the SQL to join two dataset tables. Before we move on, you can see over here that inside the tables, we have here the main sales record 50K table that contains all the columns related to the complete sales figure. Then the two different tables we will work on here are the dispatch item table, where the columns are only related to the delivery details, which are also the part of the main table. And the other table that we have is the item sales detail. Here we have 10 columns, which represents the finance figure for the sales. And these columns are also part of the main sales record dataset table. Now we will work around with this dispatch item table and the sales item table. We will combine them to look like a complete table that we have here in the form of the sales record 50K. Let's see how this can be done. First, I will select all the rows that are inside the dispatch item table. So you can see we have these 5 columns in this table. One thing you need to notice is that we have the order ID in this dataset. Next, I will run the same query, but this time for the item sales table. Here we have the same order ID column in common with the dispatch item table. So we will be combining these two tables with respect to these order IDs. Whenever the order ID matches for both the tables, the data point for each of that row will be merged and combined into a single dataset point, resulting in a complete dataset with the help of the join statement. Here I have the SQL script to join the two tables. So here I am saying that we will select all from the item sales table and then join it with the dispatch item table, with a condition on satisfying that order ID of both the table matches. So what it will do is it will compare the order ID of both the tables, and then it will merge the data from this table to this table and provide you the output. Let's run this query. So you can see over here that we have got all the columns which were in two separate tables into a single table. Here, if you notice, the query will only return you the first 5,000 rows. To get all rows, you need to click on the All Rows option and then run this query. Now, once the dataset is combined, you can click on the Export link here, and then you can export this joint dataset in the format of your choice. You have 3 formats: the CSV, the text, and the XML file. I will download it in the CSV format. Here it is downloaded. So this is how you can perform the join function using the SQL query. In your next lab session, we will look into the SQL aggregation functions. Hello and welcome to this lab session. In this lab session, we will be looking at some of the aggregation functions used in SQL. So the aggregation functions involve the count function, summation, average, standard deviation, variance, and all such functions. We have seen the count function in the beginning of this section. Now let's see one of its detailed example. Here is a SQL query I have. It will create an output table for us with the values for a count of distinct item type. When we run this query, we get the count as 12. And you can see that we don't have a column name here. Let's give this column a name. And this is done using the as keyword, which gives an alias to the output column name. Let's give it a name as item type distinct count. When you run this query, so now you can see that we get this column name here that we assigned. Now I have a query here with me. This will count the total distinct item types and label it as total item type. Then it will count the distinct region. We have labeling it as total regions. And then counting the total distinct sales channel in our dataset, labeling it as a sales channel. Let's run this query. So you can see over here that we get the output. In our complete dataset, we have 12 different item types. Then we have a total of 7 different regions and 2 different sales channel mediums, which are online and offline. This is the use of a count function, like where you can use it. Next, we have the aggregation function, which is the sum. Here is a query. We are calculating the sum for all the values in the total profit column and labeling it as total profit value. Let's run it. So this is the total profit value, which is the total sum for the total profit values in the dataset table. And it is more than 19 billion. Now let's perform the sum with a conditional statement. So here we will calculate the sum for the total profit with conditions for satisfying the sales channel to be as online only. Let's run this query. So you see we get the answer around 9.8 billion, which is the total profit made online. Let's also check it for offline. And this is around 9.75 billion. This is how you perform the sum function in SQL. As we have two sales channels, let's create a comparison table to see both the figures for the total profit of online sales and the offline sales. Alright, so we have the statement here which says that select sum. For the case when the sales channel is offline, then it will calculate the total profit sum, else it will return 0. And end the statement. The sum for this case will be labeled as offline profit. In the next line, we are calculating the sum for the case where the sales channel is online, and else it will return 0 and end. This sum will be labeled as online profit. So our output will have two different columns for the online and offline profit total sums. Let's run this query for a quick comparison. So you can see here that we have the two values, the offline profit as around 9.74 billion and the online profit around 9.78 billion, which shows that the online sales were a bit more profitable than the offline sales for the dataset we have. So this is how you perform this sum aggregation function in SQL. In our next lab session, we will see how to perform the average function in SQL. Hello and welcome to this lab session. In this lab session, we will see how to perform an average function using SQL. An average basically tells about the central or typical value in the dataset we have. To perform the average, I will write a query over here. To calculate average, we use the keyword AVG, and we will calculate average of the total profit, labeling it as average profit. And we will calculate it from our sales 50K dataset. Let's run this query. So we get the output here, which is this value over here. Now let's calculate the average with some specific condition. Here we have a SQL query for a conditional case where we will calculate the average of the total profit where the item type is only household. So I will name it as average profit for household items. So this will give an average for the household item on execution. Here is the result. This is the total profit average for the household items sold. Let's perform some more exercise on this. And this time we will use this query. Here what we are trying to do is calculate the average for two different cases, where the first case is the sales channel being offline. When the condition meets, it will calculate the average profit value, else will return 0. And end the statement, and naming it as offline average profit. In the next statement, we will calculate the average total profit for the case where the sales channel is online. So we are not calculating these averages for the entire dataset, but only for the household item type. So let's see which sales channel gave the maximum average profit for the household item types sold in our dataset. Let me run the query. So here we have the offline and the online average profit values. We can see that the maximum average profit is in the offline case. This is how we perform the average in SQL. In our next lab session, we will see how to calculate the extreme value calculation and sorting in SQL.